The tangent line problem was one of the problems that European scientists were working and mathematicians were working on during the 17th century. And the difference quotient, as we know from before, is fx plus h minus fx over h over theta x. To find the slope of a secant line is basically y2 minus y1 over x2 minus x1. So we'll take f c plus theta x and subtract it by y1, which is minus fc over, we put an m equals so that we know it's the slope, over x2, which is c plus theta x plus theta x minus c, which is going to cancel out and become fc plus theta x minus fc. The slope of the tangent line at point C, FC, the equation is going to be y minus f of c equals to mx minus c. Periodically, you're going to be given a vertical tangent, and if you take the limit and you find that is either infinity or negative infinity, then that's how you'll know you're going to have a vertical tangent. Can be f prime of x, y prime, or dy over dx. The derivative of function f of x at point x equals c is f prime of c equals to the limit of x approaches c of f of x minus f of c over x minus c. The right-handed derivative at a would be limit of h approaches 0 from the right, f of a plus h minus f of a over h. And the left-handed derivative at b would be limit of h approaches 0 from the left, f of b plus h minus f of b over h. Does continuity imply differentiability? No. For example, consider the absolute value function of f of x equals the absolute value of x. This function is continuous at x equals 0 because the limit of x approaches 0 of the absolute value of x equals 0 equals f. I apologize about that. However, it is not differentiable at x equals 0 because the derivative does not exist at this point. In this case, the function is continuous but not differentiable at x equals 0. This illustrates that continuity and differentiability are distinct concepts in mathematics.